Assalamu alaikum. My name is Hossein Ahmed Alvi, and today our object is to find square root of a number by using C programming with the C program, and we are not allowed to use any built-in function of C. So other than built-in function of C, we can use linear search, binary search, and three is Heron method. And first we will find the square root by linear search process. Okay, then I have written some code here. Int main print this program compute this is square root of a real number, and then new line double value equals to get value. User will give a value, then double result equals to compute square root by linear search. This is a user defined value. So you see, C doesn't have this, so this is new here, and this is top down design. So here I have written that print f the square root with linear percentage long float. This long float represent this value, and this long float represent this value. So that is it. Now let's run this. Compute square root by linear search. Let's fix this thing at first. As we can see, linear search or sequential search. First, user will give a value, the initial, so the initial guess will be 0, and also the final guess will be that value. If we increase this guess by plus guess plus, if we do this guess plus 0.001 and gradually increase this thing, at some time we will find the desired value. How? We will use this form like this. So we will use this formula, error equals to guess into guess minus value. If we use this, and at some point we will find the desired value, that is square root. Now let's start. As we can see, the initial guess and the final value is final guess. So here we can use for loop. Why? Because if we know the initial value, so we know where to start and where this thing will end. So you will compute this thing and compute, and now you will compute square root by linear search. We will compute this function. At first, since we can say that double closeness, at first we will give this double closeness equals to 0.01, and we have to define this thing. First of all, we have to move forward, and this closeness is 0.01, so the guess will increase 0.01 like, and this double closeness does this thing. If we can find the number and multiply by itself and close to the value within the range 0.01, we say that we found the y, or we found the guess. That's the result. That is the closeness does. Now we said we will use for loop. So for you, as these all are floating numbers, so we are using double here. Double, first double guess equals to 0. This is our initial guess. Then a semicolon, guess is less than or equal, guess is less than or equal 0 point value, semicolon, guess, we will increase guess, u guess equals to guess u guess plus 0.001. If we increase the closeness value, if we smaller the closeness value like this, so many zeros, after point, the value of the we want we will gradually be much precise. So to compute this thing, we for linear search we will use this formula: error equal guess into guess. This formula here, error equals to guess into guess minus value. Here this error, when this error comes less than 0, less than comes close to 0.01 this value, then we have our answer. That is the main thing here. Now here guess will be positive or negative, we don't care, we just have to take the apps error equals to f's value this is a value, sorry, error. We will, this formula will be applied here, error. Now if f's error is less than or equal 0, closeness, f's error is less than or equal closeness, then we will just return the return guess. Sorry, this will be, this line will be on for loop, in for loop. Or return value, or return -1. As everything is here is double or floats, that's why we are using this. So if we find the answer, this will be the answer, or if we don't find, if f's error is less than or equal closeness, then return guess. Then if we didn't have the any answer like root over minus something value, then this will happen, return -1, because inside root there can be. Now run this. Now let's try the, now let's correct this f's value. This user defined value equals to double error, wait, double absolute value. See, let's copy paste it. Here we can see that here we can see that double f's value, user defined value, equals to double value. If value is less than or equal, less than 0, then this will return minus value, or else value is greater than 0, then it will return plus value. Now for fixing the other things here, we haven't used this error. Everything here is error. Everything here is double, so let's fix this thing. Double error equals to 0.0 and double f's error equals to 0.0. Now if we run this program, if we try to run this program, what will happen? It's loading. Now it's 5, it returns 2.23390. yeah, bingo, we have done it. Now if we try to guess how many times it took to find this value, we can simply use this thing like this. If we want to know the mm, number of guesses. Let's just put second braces here, then just simply print number guesses equals to the num of guesses percentage d is a placeholder of num of guesses. Now we have to include this variable here like this. This is also, this is an integer, so you have to put int before it, as we are counting number of how many times it took, how many times how many times it took, took not how many times to find the num of cases. Just put 0, that's it, just 0. Here we are not using any float. Then just do num of cases plus plus, so that every time will increase +1 +2 +1 every count. Now if we try to run this, then let's watch what happened. Control R, 5 equals to the number of guesses, it took 22,339. Oh, that's all. Now if the guess if the if the value is less than 1 or greater than 0, like this, then 0, then we have to do something like this. Then we have to bring those lower limit and upper limit. So if we have to, this is a double, so DUPL double, lower limit equals to 0.0 and upper limit equals to value. Now as we know, inside a root always there must be always a positive. So if the value is less than 0, then this process will just make it positive, so that now if the value is equals to 0 or equals to 1, then if we say this, then this will return the value. That means 0 will be 0, root 0 equals to 0 and root 1 equals to 1. Now let's run the program. Let's watch. If we put -5, it shows this thing, it turns this -2 +5, so it's normal. If we say it's 0, it's 0. If we say it's any number you want, 88, then it shows this thing. So we have done it. Thank you. Assalamu alaikum.